Ah, the majestic butterfly, such a light and airy caterpillar. But how many butterflies do you think it'll take to overpower you?
Oh, hey, I didn't see you there. Have you ever wondered how many butterflies it would take to overpower you? Yeah, I haven't either, but Bobby Duke sure has. Came across this tweet by Bobby Duke asking, how many butterflies do you think it would take to overpower you? Well, Bobby, you're in luck because I can't think of any better way to use 4 years of engineering school to answer this question for you. Actually, I can, but that's not the point. The definition of overpower is to defeat or overwhelm. And so to me, thinking about how a butterfly can overpower you, I would think if a butterfly can physically hold you down or carry you away, then technically the butterfly would be overpowering you. What we're going to do today is we're going to solve for those two instances. And for simplicity, we're going to consider just the average human being. So, let's get started.
Now let me get this going. Okay, so we're gonna first look at how many butterflies it's gonna take to hold you down, then how many butterflies it takes to fly you away. But we also need to know what it takes for a butterfly to create lift, because we're gonna use that and put back into these equations. So let's get started. Okay, so we got a little ground here, and what we're going to look at is the sum of the forces. So this is Newton's law of motion, and saying that the sum of forces equals mass times acceleration. But we want this to equal 0 because we want our forces to be equal to the point that nothing can move. So now we're going to write our sum of forces. So we're going to pick a point, say right about here, and we're going to write and show our forces that act on this point. The first thing we need to think about is we need to know first is the strength. So how much can a human actually push? And that's going to be in the upward direction towards the butterflies as we're trying to push them away and get them off of us. And the second one is actually going to be the weight of the butterflies. So we have the weight of a butterfly coming down on us, but we don't have just one butterfly, we're going to have multiples. So we need to find a way to represent that. So let's go ahead and assume x is going to be equal to the number of butterflies. And now what we need to do is we need to multiply the weight by the number of butterflies. So we're going to have the weight times x. And now let's go ahead and write out our equation.
Whoa, hold on there. Math? Yeah, I'm out. I don't care how many butterflies it takes. So it's not that difficult as long as you focus on the diagrams instead of the math part. So let's go ahead and let's just cut to it. You'll see what I'm talking about.
So we're going to assume that upward position is going to be positive. So anything that goes up is going to be positive. So we have strength, which is going to be positive, and then a negative WB, which is the weight, times x. And that's going to be 0, because that's what it said. So then we're going to move the weight of the butterflies times x over to the other side, so that we get WBX equals S. And if we solve for x, that's going to give us the equation we need to solve for the number of butterflies, x, that it takes to hold someone down. So x is going to be equal to strength over weight. Next, let's solve for how many butterflies it's going to take to actually carry someone away and fly away with them. So we got a little ground here, put a little tree. Oh wait, never mind. Let's focus. Okay. So on this one, we're going to have the sum of forces is going to be greater than 0. And the reason why we want that is So we know the sum of forces equals mass times acceleration. And if we have mass times acceleration equals 0, then we know acceleration is 0, and without acceleration, nothing is moving. So if we have acceleration greater than 0, we know that it's actually going to be moving. The first force we're looking at is the actual weight of the human. So the human's pushing down, but we also have to account for the weight of the butterflies, because it's also going to be mass that the butterflies have to carry away. And the second one is in the upward position is going to be lift. So this is the amount of lift the butterflies are creating. But we got to remember that we're going to have more than one butterflies, so we need to multiply the lift and the weight by x. And that pretty much sums up the total number of forces that act on this body. So now we need to write out our equations in the form of the sum of forces. So again, we're going to assume that up is positive, so we're going to have lift times x minus the weight of the butterflies times x, since this is in the down position, and then minus the weight of the human. And now we're going to put this being greater than 0. So again, if we take all this and we solve for x, then we're going to get the equation that we need to find the number of butterflies it takes to carry someone away. And that comes up to the number of butterflies must be greater than the weight of the human divided by the lift minus the weight of the butterflies. But we still have this lift here. Now, we don't exactly know the amount of lift a butterfly creates, but we can estimate by actually doing the free body diagram on the butterfly. So we have the weight of the butterfly, and we have its lift. So its weight's going to pull down, lift's going to lift up, and we know that the lift must be greater than its weight to create flight. Okay, so now that we have our equations written, now we know what we need to find. We need to find the average weight of a person, the average weight a person can lift, the weight of an average butterfly, and the lift created by the butterfly. So with these four things, we know the weight of a human is this. The strength of a human, most humans can lift about 120% of their body weight. The weight of a butterfly is this, and we can assume that the lift of the butterfly can be just slightly above its weight, and we know that'll achieve flight. Okay, so we looked up all our values, and this is pretty much all we need, but we need to change a couple things. So everything we have here is technically in kilograms, as you can see. But we need to find a way to get it into a force. And the way we do that is we know that force is equal to mass times acceleration. And in this case, now, we could say that acceleration is actually gravity. So by multiplying the mass by gravity, we can actually find out what the force is. So to get all these, you notice we're using newtons, and the reason we use newtons is pretty much a simple explanation, and that is because imperial units, well, they suck. So that's why we're not going to use them. We're going to stick with metric, and I hope you remember that, because hopefully eventually we just go straight to metric. And as far as finding the strength, what we got to do is we got to take this value, which is the weight of the human, and multiply it. Let's see, weight of the human, and we're going to multiply it by 1.2, and that'll give us the 120% of the body weight and give us in a force. And next thing we need to do is we need to multiply this by gravity to give us of force, and then the same with lift into force. And once we have all these, then we can just take these values, then we just shimmy on over here, and right here. So then we can just take these, put them into our equations, and boom, we get an answer.
Hey everyone.
It's done.
Okay,
So it would take 190,000 butterflies to physically hold you down. And it would take 792,000 butterflies to fly away with you. Now, to put this in perspective, if you line the butterflies up end to end, the line to hold you down would be 15 miles long, and the line of butterflies to carry you away would be 50 miles. So if you're more of a visual person, let's assume that this green ball is us. And the volume of butterflies it would take to hold you down can be represented by the volume of this ball. And then the volume it would take to fly away with you can be represented by this ball. And you can see, we are just almost a little speck compared to the mass amount of butterflies it would take to achieve either of these two. Now, I'm pretty sure that we're never going to run into this amount of butterflies anytime in our life. So I'm pretty sure that we're safe, that we don't have to worry about either of these two happening. With that being said, I hope you liked the process of figuring out how many butterflies it would take to overcome a person. And I hope you feel a little bit smarter. But if you like this video, hit the like button. If you want to see more, subscribe. And if you want to just know more answers to dumb questions, just put it in the comments. And I'll be more than happy to read it.
So,
Watch out for butterflies, especially a lot of them. See you on the next one. Bye.